the average. And so the number of samples isn't going to really matter, except that the more you have, the more accurate it's going to be.
Okay.
But it would depend upon what you're looking at, I think.
Okay.
Yeah. Well, and the concept too of n, you know, what they consider to be a large sample size, like n is greater than 30 or something. So, I mean, I think as long as it's consistent, I mean, I think it's gonna be similar. Whether you have 150 or you have 190 or something like that, I don't think the change is gonna be that drastic. But that's a good point, though. I noticed the same thing and kind of wondered, but
okay. All right. Sorry.
So number 4 is the test statistic for a hypothesis test comparing two means with independent samples is a t-score.
Score.
Two samples are independent if. Sorry, did we all agree on t-score on that one?
Yes.
Yeah.
Okay.
Yeah.
Two samples are independent if knowing which subjects will be in group 1 determines which subjects will be in group 2, or knowing which subjects will be in group 1 tells you nothing about which subjects will be in group 2. Isn't it the second one?
Yes.
Mm-hmm.
Okay. For the next 6 questions, use the data file dentist office bills. So let's pull that up and put the information into the, let's see. So we're supposed to let, it looks like group 1 needs to be the mean bill. So it needs to go Idaho Falls and then Rexburg.
Doesn't let me open it. Oh, I can't get the file to open.
Maybe I can I share my screen?
I don't know if I can copy and paste it though.
Well, you wouldn't need to because I've already done it. So,
Okay, I got it.
Oh, do you? Okay.
Yep. Just took a very long time.
Okay. So it says perform a hypothesis test to determine if the mean bill at the Idaho Falls office is less than the mean bill at the Rexburg office. So 1 is going to be less than. Okay. And our level of significance, it looks like, is 0.1.
So that's
What is the
0?
So,
So it's 90%, not 99.
correct.
It's 0.1, not 0.1.
Yeah.
0.10.
Oh, okay.
And then we're also going to make sure it's less than.
Mhm.
So degrees of freedom, it looks like 37.996. Is that what you guys?
Yep.
No. Gosh, dang it. So, did you guys plug it into what? The 2 sample t-test?
Yes.
Correct. So did you make sure that Idaho Falls is it 327.41 is the first one in variable 1?
Yeah.
And then 511.27 is the first one in variable 2?
Yeah.
And then your confidence level is 0.9?
Okay, let me change that. Okay,
And then the type of test is less than.
less than, yeah.
And then what does it show your degrees of freedom is?
37.996.
Yeah, that's what we have.
Okay.
Oh, I thought you guys said 9 something.
No, that's right.
I think my thing my computer cuts out.
I probably did.
Okay. Not going crazy. Okay.
Okay, and then the sample standard deviation for Rexburg. Let's look at that.
We have 206.637.
So the sample standard deviation of variable 206.637. Is that what you said?
Yeah, that's what I got too.
206.637.
Okay, so 206,637.
Yes.
Okay, the next question is what is the test statistic? Which it looks like negative 0.434.
That's what I got.
Yeah.
And the p-value 0.333.
Yeah.
Yeah.
Okay. So P is greater than A.
So we
Let's
fail
see.
to reject.
Yeah.
Yes. Okay, suppose instead you had used the alternative hypothesis where they're not equal to each other. What is the correct decision based on this evidence?
We'd
Well-
still fail to reject. Mhm.
So the p-value would increase, so it would get bigger, so we would still fail to reject,
So,
which means,
B or D?
yeah.
yep, we have insufficient evidence that the mean density between the two cities are different.
I would say B.
Yes, because we're looking to see if they're different. I would also go with B.
Because the
B.
null hypothesis is that they're the same, right?
Right.
Oh. Okay, it looks like we've got to pull up another document. Fresh dinner. So we need to do the mean number of times a month. So Colorado needs to go in the first column.
Ah, I just did it wrong.
Me
So
too.
Colorado goes in the first column.
Because they can't just make it easy.
Let's do controls. Down, right.
And then Utah.
I'm glad you caught that.
Usually that stuff slips right by me, but I just happened to read it over, so I thought I'd say it out loud.
I appreciate that.
Can you take my test with me?
I always have to read over the question like 4 or 5 times just to make sure that
Yeah.
it's the little things like that that I usually mess up. So so we're looking at, let's see.
Okay. So we have 10. The n is 10 in variable 1 and 12 in variable 2. Is that what?
Say that one more time.
The n is 10 and 12.
Yes.
Okay.
Yep.
All right. So use this map.
And then we have a 0.95 confidence interval.
Oh,
And we have, let's see, use this one.
And is it,
And
it's
then we're
not,
just, yes. Yep, just that they're not equal to, it looks like.
okay.
And so we're looking at the alternative hypothesis is going to be B then.
Mine's giving me weird. It's like saying n is 0 for everything, but I've got this stuff in there.
It's showing what, Jennifer?
It's showing n is 0 for both mine, and I'm getting the div divided by 0 thing. Let me try this again. Sorry.
Maybe try pasting them in there or something. Maybe
Yeah.
something happened.
Hmm. Oh, I see that. That is so weird.
Did it work?
No, let me close it and open it again.
Okay.
Go ahead and go on ahead if you want.
What is your guys' T-score showing, your test statistic?
Minus 0.845.
Is it negative?
that's, yeah, that,
Minus.
yeah.
So negative 0.845, okay. And what is your p-value showing?
Oh no, 0.410. 0.411.
Okay,
411, yeah.
mine too. So 0.411. So our P is 0.411. Our A is
0.05.
0.05, right? So the P's greater.
So we've
Jennifer, is it starting to work for you yet, or
No, I'm going to do another one.
say that one more time?
No, it's not. I'm going to download it again.
Okay. So on 15, did you guys go think B?
Yes.
Yeah.
Okay. So now they want us to do a 95% confidence interval. So which we already have in there. Let's see, determine the margin of error for the 95% confidence interval. Okay.
So that would be
It doesn't give that to us in the software, does it?
Yeah, it does.
is that
Doesn't
minus 5147 to 2.214?
Oh
Yeah.
yeah, we subtract those and then divide it by 2, right?
Right.
So when you do that, though, do you do negative 5.147 minus 2.214, so you're going further into the negatives?
Mm-hmm.
Okay.
I got negative 3.6805.
Yep, that's what I got too.
Is
So
that,
3.
I thought that we subtracted the low end from the high end.
I have it in my notes written down somewhere. Let me just. So
have
it says the margin of error is half the width of the confidence interval. So it's the difference of the two intervals divided by 2. So you subtract the upper minus the lower and divide by 2.
So divided by 2, I get negative 1.466.
So I think you're right. I think you do take the
2.214 minus
Yeah.
minus 5.147.
because I think you're right. You do the upper minus the
Yeah,
lower.
but what did you get?
Minus
So what did you get, Jeannie?
1.467.
Because when let's see, so I do 2.214 minus,
5.
actually you're adding that 5 to it,
No,
right?
no.
Because you're
Yeah.
minusing a negative number.
It's true. So ultimately, it's like you're
Oh.
adding them together.
Right. So instead of a negative 3.681, it's a positive 3.681. Because when you minus a negative number,
You're adding them.
Yeah. essentially adds it together.
So did you then get you got a positive 3.681?
681.
Does that make sense?
So no, let me just do the math.
Okay.
Like if you put it in your calculator, just like that.
So minus 5.
No, minus negative 5.
Minus 2.214. So you get a 3.68. Is that what you said?
Yeah. Did you minus the negative 5 from the 2.214?
Mm-hmm.
I
And
guess
does it still give you-
we could check it with the formula, I guess. Where you take the t-score and you multiply it by the square root of s1 squared divided by n1 plus s2 squared divided by n2.
I can't find where she had the link for those 3 sheet. Do you guys know where that link is?
Inference.
Yeah.
It might have been.
I know they're in the textbook.
Are they?
Yeah.
Oh yeah, that's probably a good place to pull it. So do we think 3.681 then for that margin of error for the 95% confidence interval?
I do.
Yeah.
Did you get it? No, Jeannie, did you?
Yeah, I mean, I get it.
Okay.
So if we're inputting the lower bound is negative 5.147. And upper is 2.214.
want me to submit it?
Sure.
Okay.
We'll see if we did that margin of error one right.
I'm glad they make sure you really want to submit it.
Yeah, 16 times.
Positive. Okay. Yep, we did it right.
Okay.
Okay, so it is the upper minus the lower, and then you divide it by 2. Okay.
Mhm.
Awesome.
So next week we have another test. I know.
Are the tests cumulative? Like they cover everything else we've covered as well, or is it just the sections that we've?
I think they're cumulative.
Like each test though, or just the final? I don't know.
Oh gosh, if it's cumulative, that's tough.
Yeah.
There's so much information.
How are you doing, Jennifer?
Still looking. You guys don't have to wait.
Oh no, it's no big
No,
deal.
you're fine.
Let's see.
I can stop the broadcast though. We don't need to.
Yeah.